Hello everyone. Today I am going to discuss the sixth problem of AtCoder Beginner Contest 266, which is well-defined path queries on a Namori. So, what are we given? We are given a connected, simple, undirected graph G of n vertices and n edges, and we are also given two queries such that we have to identify there is a single path, unique path between xi comma yi. So let's figure out what is the problem. So there is a simple graph G given to us with n vertices and n edges. So n vertices and n edges. So this n edges thing, what do you mean when an undirected simple graph has n edges? It means that there is exactly one cycle in the graph. Now this is the first example given to us, and we can see, as I defined, that if there is n vertices and n edges in a graph, simple undirected graph, and connected obviously, then it will obviously have one cycle. You can take another few examples, and check if this statement holds or not. I can prove it, but as there is time shortage, I am not going into the proof. So let's say there are three queries: 1 to 2, 1 to 4, and 1 to 5. So there are three queries: 1 to 2. So 1 to 2 has two paths. First one is a simple edge from 1 to 2, and second one is from 1 to 3 and 3 to 2. So there is the first query. So the answer will be no. Second query is 1 to 4. There is only one path from 1 to 4, which is an edge from 1 to 4. And another one is 1 to 5. So the first path is 1 to 2, 2 to 5, and another one is 1 to 3, 3 to 2, 2 to 5. So the problem, like the implementation, is quite harder, but the logic of the problem is quite straightforward. The logic of the problem is that if two nodes are connected in a cycle, okay, part of a cycle, and we are in a query where we are, let's say the query is I comma j, and I is part of a cycle and j is part of a cycle, then our answer will be no. Okay, because there are obviously more than one path between I to j. One will be like, if there is a cycle and we are at this point and this point, so there are exactly two paths. One is from this path, the clockwise direction, and another one is anti-clockwise direction, you can say. So this path and this path. So if two nodes are part of a cycle, then the answer will be no. And there are other few cases. So let's say this 4 and this 5. Okay. So let's say 6. Another age is from 4 to 6, and another is 5 to 7. So now if there are two nodes I and j which are connected to the same node, which is part of a cycle. So 5 and 7 both are connected to 2. Like this is the branch from 2. So 5 and 7 both are connected to 2. So the answer will be yes in this case. Or if there is another part of a cycle, 4 comma 6, so 4 and 6 both are connected to 1. So the answer will be yes. But if 4 and 6 are connected to 4 and 5 are connected to different parts of the cycle. So 4 is connected to 1 and 5 is connected to 2. So the answer will be no in this case. So another case which you may ignore is that, let's say another case, this is 1 to 8 and 8 to 9. So if we query from 4 to 8, the answer will obviously be yes, because they are connected to same part of a cycle 1. So that is the logic. So let's go into the implementation part now. So what I am doing, let's go into my code. So here what I am doing in the first DFS, this is the first DFS where we are marking the cycle. Okay, so what I am doing is that, let's say this is a cycle. So you can check out the code of how to find a cycle in a undirected graph. So we are doing a DFS 1 to 2, 2 to 3, 3 to 4, and when we are checking that one is already visited, then we will do some kind of backtracking from code. So we'll mark this as visit. Sorry, this is a part of a cycle. So cycle of 4 is 1. Cycle of 3 is also 1. Cycle of 2 is also 1. Cycle of 1 is also 1. So this is kind of a backtracking. You can check out my code. I will give you the link of the code in description box. Also you can find it in GXG or any YouTube channel. So let's now go into the second part. So first is DFS1. The first DFS is finding all the nodes which are part of the cycle. So let's say the previous example, 1 is part of a cycle, 2 is part of a cycle, and 3 is part of a cycle. So these three nodes are marked as 1. Now what I am doing in the second code, this is I plus 1 is the color. Let's assume it is color. Okay. So now what I am doing is, so let's take another fresh example here. So another fresh example, let's say this is 1, 2 and 3. So there are two nodes connected to 1, 4 and 5 and 6, 7. So this is the fresh example. So first DFS is over. So the cycle of 1 is 1, cycle of 2 is 1, cycle of 3 is 1. Okay. Now I am doing the second DFS. In the second DFS, so I am passing running DFS 2 of 1, and the color given to is 2. So 4 and 5 will be marked as 2. Now I am giving color as I plus 1 because let's say 1 is already occupied because cycle of 1 is 1, so I am doing giving the color I plus 1. Now the color of 6 and 7 will be 2 plus 1, so it will be 3 comma 3, and there is no node connected to 3, so let's forget about it. So now there is the checking part. So the DFS2 is over. Now I am taking input as x comma y. Now there are four conditions given by me. So first condition is both are part of a cycle. So let's say one and let's say the query is 1 and 2. So let's take another color. So let's take uh, brown. So let's say the query is 1 and 2. So both are part of a cycle. So the answer is no. Okay. Now both are not part of a cycle. So if both are not part of a cycle, so it could be 4 and 5, or it could be 4 and 6, or it could be 6 and 7. So if both are connected to the same part, so if cycle of 4 is equal to cycle of 5, so cycle of x is equal to cycle of y, then the answer will be yes, and otherwise the answer is no. So if it is 4 comma 5, then the answer is yes. If it is 4 comma 6 or 5 comma 6, the answer will be no. Now the second case is that if either of them, like one of them is part of a cycle, so it could be x or it could be y. So let's say this is 1 and 5. So if you can check this case similarly. So if 1 and 5 is given to us, then the answer will be yes. So if cycle of x is 1, then we are checking if that the cycle of y is x plus 1. So what does it mean? So it is connected to 1 or not. That's basically what we are doing. So what we are doing is that if we are checking if cycle of y is x plus 1 or not. If it is cycle of y is x plus 1, then the answer is yes. Otherwise the answer is no. Similar case will be for y also. If cycle of y is equal to 1, and we are similarly checking if cycle of x equal to y plus 1 or not. I hope you got my explanation. If you still have any doubt, you can always ask me in the comment section. Please like the video and subscribe to my channel. Thank you.